Hello guys. So we are going to continue our discussion with respect to Python, and now we are going to start data structures in Python. Some of the most common data structures that are used in Python programming language are lists, tuples, sets, dictionaries. In this video, we are going to focus more on lists. So let me just go ahead and show you the video outline. Introduction to lists, and then creating lists, accessing list elements, modifying list elements, list methods, slicing lists, iterating over lists, list comprehensions, nested lists, and practical examples and common errors. So, what are lists? Just to give you a definition, lists are ordered, mutable collections of items. They can contain items of different data types. Let me just go ahead and show you how we define the list. So lst is equal to, suppose I'm creating a blank or empty list here, and I'm trying to print type of lst. So I just want to see what is the type of this variable, and it says class list. Okay. Now let's go ahead with some examples. Names is equal to, I'm creating a list here. Okay. And I'm assigning some names here, Ipshita, Mona, Vedika. And also I'm giving some numbers here just to show that it can hold different data types in a single list. 1, 2, 3, 4, and 5. Okay. If I do print of names here, this is how we create a list, and we'll see the output here. So it printed all the items or all the elements in the list here. Now let me show you another example of a mixed list here. Mixed list is nothing but, again, different data types in a single list. Mixed list is equal to 1, comma, hello, comma, then we are going to write a floating number, then Boolean value. Okay. And then when I do print of mixed list, let us say the value or the output here. So 1, hello, 3.14, and true. So let's see how we can access the elements or items in a list. Accessing list elements. Okay, so I'm creating a list called fruits here, and I'm going to add fruit names here: apple, comma, banana, comma, cherry, comma, kiwi, and then let me add guava. Okay, so this is a list of fruits. And here in Python, right, the index always starts from 0. So apple is at index 0, and then we have 1, 2, 3, 4. The fourth index is guava. So if I want to access the elements in this fruits list, what I can do is, let me just print fruits of 0, 0. Okay. So if you see here, oh, sorry, I did not execute the cell. That's why I got this error. Okay. Okay. So the 0th index of the fruits list shows me as apple. Okay. And then if I print the same for another index, suppose 2. So what should it print? 0, 1, 2. It should give me the output as cherry. Okay. It gave me cherry here. Let me do it for another index 4. We'll see. So ideally it should be giving 0, 1, 2, 3, and 4. Guava. It should be printing guava here. Yes, you're correct. It gave us guava for the fourth index. Now if I try giving the index as -1, it should give me guava, because -1 means it should be like processing from the reverse order. So guava is the last element, so -1 is the last element here. So let's see. Yes, it gives guava here. So we are able to retrieve any item in a list just by using indexing. Okay. So now if I want to retrieve all elements from banana till the end, or the last element in a list, what I'm supposed to do? I am going to write different parameters here. Like if I give print roots, and within this, if I give colon, colon. So if you see we can pass three parameters here. The first one is the start parameter, second is the stop parameter, and third is the step parameter. So this one we already discussed in our last session on loops. So you can go through that video to understand more on loopings and also these parameters. Okay. So, okay, now what was the question? I wanted to retrieve all the elements from banana till the end. So what I'm going to do is, so banana will see the index. What is the index for banana here? 0 apple, 1 banana. So banana stands for 1. So my starting parameter would be 1. And from till end, so I'm not giving anything here. It should be default if we do not give anything. It would take all the elements till the end. And this one, the third parameter, which is called the stop parameter, if we do not give anything, it will take the default value as 1. So let us print this and see. Okay, so it gave me banana, cherry, kiwi, guava. Okay. Now, if I want to just print the index, just print the elements starting from index 1 till index 3, what I'm going to do, I'm going to write something like this. So what it will do, it will start printing the items or elements from index 1 till the third index, but excluding the index 3. So if you see the output here, it prints banana and cherry, but not the third. This is the third index. It is not going to print this. I hope this is clear. Now, if I want to modify the list elements, let us see some example on that. Modify list elements. So let us see the contents of the list fruits first. Apple, banana, cherry, kiwi, and guava. So what I'm trying to do is I'm going to replace banana with watermelon. Okay. So fruits is equal to, sorry, fruits of 1. I'm going to give the index of banana, that is 1, is equal to within double quotes watermelon. Okay, and then if I try to print fruits here, print, we'll see the output. Okay, so it replaced banana here with watermelon. Okay, let me again define the list fruits here. I'll run this and then we'll go to the next operation on list methods. Okay, list methods. So we have many built-in functions. I'll show you one by one. Fruits dot append. If you see, this is an inbuilt function, and I'm trying to append a new fruit or new element called orange to the existing fruits list. Okay, when I execute this, and if I print fruits, I can see, I'll see the last element as orange. Oh, it already has. Okay, sorry. I print because I executed this twice, orange got appended twice. Let me just redefine this fruit list and I'll run this once. You see orange ones now. Okay, because we are trying to append orange to the last element, so you can see orange got appended to the end. Okay, now I want to append an element at a specific index. So for that, what I'm going to do, fruits dot, I'm going to use the function called insert, and I am trying to append the fruit banana at index 1. So I'm going to write banana here, and I'm going to write run of fruits. You'll see the output. So now you can see there are two bananas here because I'm trying to insert another element. So we are having two bananas now. Now what I'm going to do is I'm trying to do the same and I'll insert at index 1, I will insert watermelon. Okay. So if you see here, we have apple, watermelon in the first index and rest of them follow in the same sequence. Okay, I hope this is clear. And now we are going to see another inbuilt function, how to remove an element from the list. So fruits dot remove, and I'm going to write banana here. So what it will do is it will not remove both the occurrences. Instead, it will just remove the first occurrence of the element. And when I print fruits here, we'll see the same output. You see here, it just removed the first occurrence of banana. Earlier we had two bananas here in the fruits list, but when I ran the remove function here, or remove method here, it removed the first occurrence of banana, and we are having only one occurrence here. Okay. So now let's remove and return the last element. So for this, we are going to use the method called pop method. Okay, this is used to remove the last element from a list. So pop fruit is equal to fruits dot pop. Okay, so pop is again an inbuilt function, and then I'm going to print the pop fruit, and also let me check the fruit list now after we remove the last element. So the popped fruit, so the element to be removed from the list is orange, and after we executed the pop method, it removed orange from the last, like the last element. Orange was the last element, and we removed it from the existing list. Now, if you see the fruits list, we do not see the orange element here. Okay. So we have another inbuilt function which can retrieve the index of a particular, what you say, item or element. So index is equal to fruits dot index of, suppose I want to retrieve the index of cherry. If I do print of index, so what should it retrieve? If you see here, cherry is here, right? So 0, 1, 2, and 3. It should retrieve 3. Yeah, it gave the output as 3. Okay. Now I want to count the occurrence of banana. Okay. Let me just, okay, so here we have only one banana. Let me just insert another banana to this list, and then we'll go ahead with the count method. What I'm going to do, fruits dot insert. I want to insert banana at the second index. Okay. And then I want to again print the list here, just to see if there are two bananas now. Yes. So banana is at the index 2 and 3 here. So let me just go ahead and count the occurrences of the element banana here. So what I'm going to do, print roots dot count. Count is an inbuilt method, and I want to count the occurrence of banana here. Okay, let me execute this. It gave 2 because we have 2 bananas in this list now. I hope this is clear and you are able to understand and you're with me till this point. Okay, so let us go ahead and discuss some more examples and some more inbuilt methods. So we have something called sorting, right? We can sort the list ascending or descending. So let me just show you how to do that. Fruits dot sort. And if I do this and if I print the output here, we'll see it gets sorted in the ascending order. Apple, banana, then cherry, guava, kiwi, and watermelon. Okay. And now I want to clear this list out. So fruits dot clear. Clear is again an inbuilt function. Okay, before clear, I want to show you another thing. So what I want to do is I want to print print the elements in this list in a reverse order. So similar to descending. REV. Okay. If you see here, it started printing in the reverse order, watermelon, kiwi, guava. So this is ascending order. And when I do reverse again on this, it gives me the reverse output, like watermelon first, and then kiwi, and then guava, cherry, banana, and then apple. And now I want to execute the clear method, which will like remove all the elements from the list. And if I now run the print command on the fruits element, I will get an empty list here. You see this? Okay, so we are done with all the examples, basic examples. Now we are going to discuss on slicing. How do we slice a list? Okay, so slicing list. For this, what I'm going to do, I'm going to define a list here. Numbers is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, I'm having 10 numbers defined in this list, and now I'm going to print numbers, and then I'm going to perform the slicing operation here. So if I write 2:5, what it will do is it will start printing the numbers starting from the second index till the fifth index. So second index is 0, 1, and 2. So it will start from 3 and it will go till fifth index. So this is 2, 3, 4, 5. So this is the fifth index. So it's going to exclude the fifth index. It will just print 3, 4, and 5. So if we run this and see what's the output, it should be 3, 4, and 5. Okay, let me give some more examples on this slicing for your better understanding. But I'm going to do numbers. Now I'm going to do something like this. So the first parameter I'm defaulting it, and the second one I'm writing it as 5. And next I'm going to do print numbers, and what I'm going to do 5 and then colon. Okay, then print numbers. This time I'm going to default the first two parameters, and the second one I'm passing it as 2. And then another example, print numbers, and within this I'm defaulting again the first two, and the last one I'm giving it as -1. So just pause for a second and try to think what should be the output for each of these print statements. And then you can come and check the solution if we are correct. So if I run this, if you see here, first one we already discussed. Second one, we are defaulting the initial parameter to be like it should consider the starting element as the first parameter until fifth index. So fifth index is nothing but this value. So excluding 6, it should print 1 till 5. Similarly, fifth, it starts from fifth index, so it will start from 6 till end, 6 till 10. And then for this means include everything but with a step of 2. So it will skip the second element by default. Not by default, but we are asking Python to skip the second element. So it will print 1, then it will print 3, then it will print 5, 7, and 9. Similarly, when we give the step as -1, it should start printing in the reverse order. The last one, if you see, it prints everything in the reverse order. So if we change the step, right? So let me show an example by changing the step method here. When I do print and numbers, I pass first two parameter again. I'm defaulting. Second one I'm giving it as 3, and then I'll show another example, numbers, and defaulting first two and giving it as -2. So the same logic. So the third, this one it will give it a step as 3, and this one from the end it will skip the second element. So if you see here, it is skipping the middle two elements, or and the last one, if you see, it starts printing in the reverse order, but with a step of -2. Okay. Okay, now we'll see another concept on iterating over list. So in our previous video, we have already discussed on how to iterate over strings. Today we'll see how to iterate over a list. We'll be using a for loop for that. Okay, iterating over a list. So for that, let me write a for loop here for number in numbers. So numbers is nothing but the thing that we already defined here in the above cell, right? So this one, we are just taking this again. Let me just copy this here for better visibility. Okay, so I'm writing for number in numbers, then I'm just printing the number here. So this will just iterate over this list and print the numbers one after the other. If you see here, the output is here, 1 till 10, it's printing. Okay, now we'll check how do we iterate with index. So this is just iterating over a list. But if I want to see what is the index along with these values, what I'm going to do is I'm going to use another inbuilt function for that. Iterating with index. Okay. What I'm going to do, I'm writing a for loop here for index comma number in enumerate. Enumerate is a built-in function, and to that I'm passing my list here. Okay, this will return the indexes along with the values or elements in the list. And then I'm going to print index comma number. So when I execute this, if you see, the first value is the index and second one is the element from the list. So 0, 1. So first index, in the first index we have the value 2. Similarly, in the ninth index we have the value 10 or the element 10 in the list. So this is how we iterate with index. And now let's go ahead and talk about one more amazing thing, that is list comprehension. This is very, very important. So please try to focus. Let me give you an example of list comprehension. Okay. So I'm just creating an empty list here first. And I'm running a for loop here for x in range of 10. Okay, and lst dot append x square group. So what I'm doing here is I'm creating a empty list here and I'm trying to append the square of each number within this range. I'm iterating the numbers from starting 1 till 10 and I'm trying to create square of these numbers and appending it to the list. So let me just print this list. If you see here, it's starting from 0, it gave all the number squares excluding 10. Okay, so here I have written 3 to 4 lines of code just to get square of numbers. Creating a new list and appending numbers implies more and more memory. Here we can make use of list comprehension where we can perform all of these above operations within a list itself. So let's see how it works and how to implement this list comprehension. Okay, for that what I'll do is I'll write a list here for x in range of 10. Okay, and for this for this iteration I'm going to write a what do you say expression here or operation, the operation that we want to perform on the list. So that is x square. Okay, so the first parameter would be the operation or expression, second one would be the iteration, and if you have any conditions like if condition or something, that will be written here after the for. That is the syntax of list comprehension. Okay, so now let's go ahead and run this. If you see here, the same output 0 till 81. Here also it prints 0 till 81. So this is more efficient way, and like uh, we can say this is a way of memory management also. Let's discuss another example on list comprehension with conditions. So I'm creating an empty list here, empty list, and then a for loop for I in range of 10. Okay, and then I'm checking if I percentile to double equals 0. So I'm checking it for even or odd, and if it is even, I'm appending that to the list. List dot append I. Okay, and I'm coming out of this loop and I'm printing the list here. So ideally it should print all the even numbers. So if you see here 0, 2, 4, 6 and 8. Okay, but this is one way of implementing looping in the list, but we are going to write list comprehension for the same example mentioned above. Okay, so for that what I'm going to do is the same thing for num in range of 10. Okay, list here. First the for loop and then followed by if num percentile 2 is equal to 0. And here I'm going to write the expression, that is num Okay. So, okay, expression is nothing but num. So, first thing is I'm iterating over 0 to 10 here, and I'm checking if the number modulus 2 is 0. If the number is even, then I'm going to append this number to the list. So let me create a list here, even underscore numbers is equal to this, and then I'm just going to print the even number list. So 0, 2, 4, 6, and 8. Okay. I hope you are understanding this, guys. This is very, very important list comprehension. So as and when we go ahead, we will be covering more and more complex examples. Now let's go ahead with the nested list comprehension. Nested list comprehension. Okay. So it is good to know all these things, guys. I'm trying my level best so that you will be able to understand multiple concepts. Okay. So let me create a list. List 1 is equal to 1, 2, 3, 4. Another list I'll be requiring here. List 2 is equal to A, B, C, D. Okay. So I have two lists now. I'm going to, sorry, I'm going to create a list comprehension, a nested list comprehension here. Okay, so a list here, and within this, I'm going to write a for loop here for I in lst1, and then another for. So this is for inside another for j in lst2. Okay, and for these iterations, I'm going to uh, create a pair here, pair of I comma j. So what this is going to do is it will create a pair. Pair is equal to this. Let me just print this out. Print pair. Okay. So as discussed already in our last class, last video, about the nested loops, right? What it will do first, for one value of the outer loop, it will execute the inner loop completely. So I'll show you when I execute this. So if you see here, 1 is the first value of the list 1. So when the value of I is 1, it is executing this for loop for all the variables or all the elements in this list too. So all the elements in the sense A, B, C, D. So if you see here 1 comma A, 1 comma B, 1 comma C, 1 comma D. And then it's going again to the main loop to the second element 2. Then 2, A, 2B, 2C, 2D. Similarly, it goes till the end. Okay, so this is what nested list comprehension is. And then we'll understand how the list comprehension with function calls works. Okay, I'll show you one example for that with function calls. So I'm creating a list called words is equal to and hello, and then world, and then Python, another word called list, and then comprehension. Okay, sorry. Okay, so I have a list here called words, and then I will create another list called length where I'm going to write my list comprehension. So what it will have, I'm going to loop or iterate over this words list for word and words. Okay, this is my loop. And then I'm going to find the length of each of these words. So len is an inbuilt function again, length of each of the word. Okay, and then print print length. So let's see what the output is. So if you see here, it gives length of each of the word here, like 5, 5, 6, 4, and 13. Okay. So let me just summarize now what list is and what list comprehension is. So list comprehensions are a powerful and concise way to create lists in Python. They are syntactically compact and can replace more verbose looping constructs. Understanding the syntax of list comprehension will help you write cleaner and more efficient Python code. Okay, I hope you got an idea about list and list comprehensions by now. So, this was all about the discussion with respect to list, and I think I tried my level best to cover each and every concept. And at the end of the day, you need to practice more and more to reach perfection. So, this was it from my end. I'll see you all in my next video on tuples, that is the next data structure in Python.